33 takes us into logarithmic functions, okay? Logarithmic specifically relate to exponential functions, and that's why we're here. You saw logarithmic functions in Algebra 2, though.
Yeah.
So this is not going to be brand new. It's going to be a serious heavy review, but we're going with some of the basics. Now, on these problems, I don't want to see any calculators until it says use a calculator. Okay, so this is all knowing how to work the properties and how it all connects, okay? Because these are all very doable without a calculator. I'm not even going to push you that hard.
I'm just excited for the part that says using a calculator.
Okay, logarithms. So logarithms are of the form log base b of x equals y. And that is our traditional logarithmic form. Log base b of x equals y. It can be transferred or transformed and written in exponential form, which is what we often have to do because we can't always work with log form. So we transfer it to exponential form, which is b to the y equals x. This is where the phrase left, right, middle comes into play.
Yeah.
Okay? So left, right, middle is the phrase. It's just a helpful reminder phrase. And it will help me on how I get from log form to exponential form. So the idea of left, right, middle is b is my left value, raised to y is my right value, equals x, my middle value. So b to the y equals x. Left value, right value, middle value is the kind of the order I rewrite them in. Okay? Different people remember different things. You could also, the base of the log b is the base of the power over here. And then you just flip-flop your x and y. Everyone comes up with their own little ways. What works, you come up with yours. Okay? Now, example 1, it says evaluate the following logs. So we want to know log base 2 of 8, what that equals. No, put the calculator down. I'm not using a calculator here. Besides the fact...
This equals log.
So, okay. So think of this. I'm going to say make my log equals y.
Isn't it?
So I have an equation now. Log base 2 of 8 equals y. How can I rewrite that in exponent form?
2y equals 8. Log of 8 or is it 8?
Just 8. So if we take it out of log form to exponential form, left, right, middle. So the 2 from the left raised to the y from the right equals 8 in the middle. Okay? So that's taking us out of log form into exponential form because now it becomes a much easier problem to solve. What do you know about 8? It can be rewritten as 2 to the third. And the idea, if 2 to the y equals 2 to the third, then we know y is 3. Okay? This is one of our ways we can do this when we're not using a calculator. Okay? We want exact answers. Let's try a similar thing with b. Log base 3 of square root of 3.
3y equals 3.
Okay? So again, if I set it equal to my variable of y, base of 3 on the left raised to the y from the right is equal to square root of 3 from the middle. Okay. Dig deep. What do we know about square root of 3?
It's a square, so y equals 3 or x squared.
No.
Didn't you rewrite it to 3y equals 3 to the 1/2?
Yep. Remember square roots, guys? Square roots are written as fraction exponents. Does that sound a little familiar there? The square root of 3, because it's a square root, so because there's that invisible 2 in the radical there, that 2 is called our index, that says it's to the 1/2 power. If it was a cube root, it'd be the 1/3. If it was a fourth root, it'd be the 1/4, right? So if we have 3y equals 3 to 1/2, we now know that y is 1/2. That information's in your head somewhere, right? I think everyone has that look of recognition.
I'm trying to remember it, and I understand it right now.
Obviously, I would know.
C. Log base 5 of 1/25th. I just made it equals to y. So if we rewrite this, it's going to be rewritten as 5 to the power of y equals 1/25. What do you know about 25?
Well, it's perfect. Yeah. Perfect.
1/25 is 1/5 squared. How can we rewrite 1/5 squared? 5 to the what power?
-2.
-2?
Oh yeah, when you
Oh,
put it up
yeah.
at the top, you have to change this sign.
Again. How do we get a power out of the denominator? To move it to the top, you make it negative. Or how did it get to the denominator originally? It was negative, and we moved it to the denominator to make it positive. So right there, since we had that 5 squared in the bottom, it's 5 to -2. So if 5 to the y equals 5 to -2, y is -2. You see, you're seeing a little bit of everything here. We had to talk about radicals. We have to talk about negative exponents. Let's talk about D. Okay, if we think of this as log base 4 of 1 equals y, so 4 to the power of y equals 1. Well, if we think about this like every other problem we've done so far today, 4 to the y equals 4 to what power is 1?
0.
Anything raised to the 0 power is 1. And so, is that a true statement there? It was 4 to the y equals 1. That's equivalent to saying 4 to the 0. So y is equivalent to 0.
Wait, why is it 4 to 0?
Because any power to 0 is
Yeah.
1.
Oh, I have to write that.
1. You can say
Yeah.
that 4 to 0 is the.
We had to rewrite this 1 with a base of 4.
Trust me, I didn't understand it at first, Steve. But
Yeah, and we have to rewrite that 1 with a base of 4, trying to look for the connection. So 4 to some power has to equal 1 for this to be true.
Because I would have been stumped. How do you have 4 to the
Huh?
y and then.
And here's my hope. We go through these now, you won't be as stumped later, right?
And when I'm looking at my notes, yes. Because I'm still going to be like, oh, what did we do?
Okay, last one in this row. Log base 7 of 7 equals y. So if we rewrite this with a left, right, middle, 7 to the power of y equals 7. What's the invisible exponent there? 1. So it's the idea of 7 to the y equals 7 to the first. And so y is 1. Okay, those are your properties of logs. Or those were your, basically evaluate. Now, properties of logs are going to be a little bit quicker ways to do some of the problems we just did. Property 1 says log base b of 1. So log any base of 1 is always going to equal 0. So example D right here. Log base 4 of 1, guess what it equaled? 0. We wouldn't have to do that work. Anytime log of 1 is always going to be 0. That's our first property to know. Second property, log base b of b equals 1. Anytime the base of your log and the inside of your log match, that log's going to be equal to 1. For example, example E, log base 7 of 7, what did it end up equaling? 1. We did this the long way. Properties are your shortcuts. We'll use the shortcuts in example 2 here in a moment. 3, log base b of b to the y. So again, when the base of the log and the base of the power match, when those b's match, it's equal to your exponent. Well, that really is basically a variation of examples A, B, and C. Because A, log base 2 of 8, well, that could be rewritten as log base 2 of 2 to the third. And what was my answer? The 3.
Oh.
So all of these, this could have been rewritten as 3, 3 to the 1/2, answer of 1/2. This can be rewritten as 5, 5 to the -2. So property 3 really is what we did on examples A, B, and C. Okay? These are shortcuts. And then example, or property 4, we haven't done anything like, but this is saying if you have a base B raised to a power of a log, where the bases are the same, it's equal to the inside of the log, whatever that might be. And we'll see an example like that here in a moment. Okay? So, example 2. Let's go through these. Again, we're not touching the calculators yet. Just evaluate. And this one even specifically, no, it's the next one that says it. We're just evaluating, but we're using the laws. We're using those laws up above. So, log base 3 of 27. What?
1.
No.
No?
So we want to make the base of 3 the same as the base of 27. So how can we rewrite 27?
3 to the 1/3.
So that's a lot of 3s. It's kind of confusing there, but log base 3 of 27. 27, check your math, is 3 to the 3rd, yes? 3 times 3 is 9, times 3 is 27. And so right there, if the base 3 and that 3 match, my answer is the,
So it's the number 3 on
so it's the 3 from the exponent. So right here,
the property. So you got property.
Yeah.
There's a lot of 3's in this problem.
there is, I know, it's kind of a bad problem for that, for this. But, so when we say our answer is 3 here, it's a 3 from the exponent because these 3's matched. Okay? How can we rewrite example B to use our properties?
Log 2 and 2 to the 1/2.
Okay. This is log base 2 of 2 to the 1/2 power. And so the property says, because those 2's match, what is my answer?
The exponent.
The exponent of 1/2.
So that's property 3.
Yes, both A and B both fall into the property 3 category. Okay, in other words, if you see a base and you can rewrite the inside of the log with the same base, you can use that property every time. Okay, C.
Property 2.
She says property 2.
Same base.
Log base 25 of 25 is going to equal
1.
1. The 25's match, and so it's just equal to 1. Really, you can think of it if you want. It's log base 25 of 25 to the
Are we
first
even
power if you want.
saying it equals, y equals? Yeah, because I've been doing y. I've been doing y equals.
You can. You don't have to. I mean, we're just saying, well, all we're saying is log base 25 of 25 equals 1. That's what this log equals. I didn't, up here, I was including a y because we could kind of set up an equation. I haven't been setting up an equation. I'm just trying to simplify the log.
Okay.
So you could say
But
y
if I
equals.
were to put y equals,
Yeah.
does it matter?
No, that's fine. Okay, D. 6 raised to the log base 6 of 7.
Property 4. I feel like I'm trying to check.
So that would be to the 7.
Yep.
Yeah. So
Because
6 and 6 y.
those 6's match,
So the y has to be.
then this log is equal to 7. Okay, in other words, this whole expression, if you were to put this expression into the calculator, it would equal 7. Okay? And then E, log base 8 of 1.
Property 1. Y equals 0.
Okay, log of 1 is always equal to 0. Okay, if you type log of 1, any base into a calculator, you're always going to get 0 every time.
So you could put these into your calculator.
Depends. We'll talk about that here in a moment.
Yeah.
Okay, and actually the ones we just did, cannot be put into a basic calculator.
But into this.
Maybe.
So yes.
However, I won't give you credit without work, so.
Well, but it can help me like check my answer.
Okay, common logarithms. Common logarithms, so you notice all the logs we just did, the base was listed there. A common logarithm is when the base isn't listed, we assume it's 10. So log x, if you see something log x, the invisible unknown base is 10. I shouldn't say unknown. The invisible base is 10. So, you know, if we think x and there's no power listed, we know it's an invisible 1. Well, here, when no base is listed, it's log base 10. So, and that's what your calculator works in. Anytime you see a log button on a calculator, the calculator works in log base 10. So now, these are again without a calculator. We're going to use our properties again. Okay? This one, it's log of 100. Well, what base is that?
2. I mean 10 to the second.
Okay. So
Sorry.
this is log base 10 because it doesn't say anything otherwise.
Yes.
And what do we know about 100? 100 can be rewritten as 10 to the second. And how does this help me?
Because now we know that it equals 2.
Yeah, it simplifies to be 2.
So these are x equals or just nothing? Just write 2.
It's just the log of 100 is equal to 2. That's all, that's this entire page, is the log is equal to the answer we're getting. Okay, so on this one, we're not going to right now because I don't want us to get the calculators out yet, but if you type in log of 100 on your calculator, it's going to say 2. I want you need to know the properties though, and that's what we're practicing right now. Okay, B. Log of the 5th root of 10. Well, how can I rewrite that that's going to be helpful?
1 so 10 to the 1 over 5.
Okay. This is log of 10 to the 1/5 because the 5th root of 10 is 10 to the 1/5. What's the invisible base? 10. So what do we know about log base 10 of 10 to the 1/5? So this log is equal to 1/5. What about log of 1/1000?
That's an invisible log of 10.
Okay, it's invisible base 10. What do you know about 1,000?
1,000 to the
10 to the.
But I don't want a base of 1,000.
10 to the third.
Yeah. We know 1,000 is 10 to the 3rd, correct? 10 times 10 times 10. So this is log of 1 over 10 to the 3rd, which is also 10 to the negative third. Remember to get something at power out of the denominator, make it negative. So now I've just rewritten that as log base 10 of 10 to the negative 3rd. What is this log equal to? -3. Again, any of these, you plug them into your calculator, you plug in the log of 1 over 1,000, you're going to get -3. We're using the properties right now. D, 10 raised to the log of 6. What do we know? It's 10 raised to log base 10 of 6. What is this equal to? 6. Because the 10s match, and if the 10s match, it's equal to whatever's in the inside of the log. E. Log of 1 is 0.
Because it has the base.
And it doesn't even matter if it has an invisible base of 10 on this one, does it?
No, because it's 1.
Log of 1 is always 0, any base.
Shoot. That's why I'm dyslexic.
Okay. A couple of you have been waiting for this section.
That's weird.
Okay, let's do it real quick.
Hold on.
Knock these out real quick. They are just that. They should be quick.
And you just log. Oh my gosh, I swear I was. You. Oh, okay. We're good now. Where do you guys even see logs? See, I'm not this gadgety with all
Right next to the 7.
Okay.
You're looking way too difficult.
You sound like a grandma.
I'm not good with these.
No,
Give
because
me
like Doug always is like, why don't you know how to do that? And I'm like, oh, well that's Doug. I know. He spends his free time on his calculator. That's how he's wicked math.
Okay, guys. Tough stuff here. Now, first of all, what is the base on log of 34.5? 10. Guess what your calculator works in?
Automatically 10.
Log base 10. So, what do we do to find the log of 34.5?
Log and then put it in your parentheses, close your parentheses. Whoa.
There you go. Got it?
Yep.
I believe it's 3 decimal places in homework.
253.
So approximately 1.538. Okay. What about log of 0.43?
Negative 0.367.
What happens if you can't do a -3?
You put it as a negative.
Okay, hold on. Let me finish B, please. Log of 0.43. Notice we did log of a number smaller than 1, and we got a negative value. So negative 0.367 if I'm just going 3 decimal places when I round it, right?
Yes.
And what happens when you do log of -3?
Do you put it in like 1/3? Put it in a 1/3.
Nope. You put in
It doesn't.
-3.
Imagine.
And what's it say?
Non-real answer.
Non-real answer. As in, it's an imaginary answer. Can you do the log of -3?
No.
No. You cannot do the log of negative values.
So no real.
This is what I'm going to call as undefined. Because one of the things you need to learn is that logs, the inside of the log must be positive. Okay?
I'm in the wrong mode.
So, now with this in mind, let me show you real quick, guys. Here's what the graph of a log looks like. This was one of our examples from lesson 1.2, 1.3. This is a log graph. Notice, where does it not go?
Past the line.
It does not go to the negatives, does it? Okay. Right there, there's your log 1 is 0. You will never do the log of a negative value and get a real answer.
Okay.
Okay, so that's using the calculators. Easy enough?
Yes.
Okay. Man, I thought we'd get through this today. Example 5. Solve each equation using the definition and laws of logarithms. So this almost takes us back to more like the first set of examples. It's already set as an equation, right? I don't have to make it equal to y or anything. There's already an equation, but here, log of x equals 3. Well, what base is that?
10.
Okay. So how do I do this?
So you put 10 to the third. Because
Yep.
the 3 left, right,
Yep.
Yep.
Think left, right, middle. So 10 to the third equals x. Man, hardest equation we've solved in a while, huh?
Wow. Wow.
What is 10 to the third? 1,000. Okay, B. What do you got for B? Left, right,
Log of 2,
middle.
or log of 5 to the second.
No, drop the word log. We're taking it out of log form, going to exponential. So 2
2 to the fifth.
fifth x. 2 to the fifth equals x. X is
2 to the fifth. X equals 32.
32. Okay, C. Left, right, middle. 3
1 9. Or 3
to the x is 1/9. Ah, this is more like what we had to do up top. Nope, you don't need a calculator for this.
Negative
What do we know about 1/9?
1,
It's 1 over,
3 to the third,
not 3 to the third, 3 to the second. So 3 to the x is equal to 3 to what power? When I take it out of the denominator, it's going to be -2. So if 3 to the x equals 3 to the -2, x is -2. And no. Okay, I guess we're doing D tomorrow. I'm not doing the graphs, but I'll do example 6 and 7. And then I'm going to teach lesson 3, 4 tomorrow. Hopefully we have a full day.
Okay. Fingers crossed.
And yeah, if we have a chance tomorrow, we might check. You guys have already checked the first homework, haven't you? We might check the second homework. Okay? We wouldn't fully check this homework because we have the last few to do. But it is 36 problems. We just saw how quick these things went, right? So before you start bashing 36, it's not horrible.
I'm gonna bash it anyway.